We're going to try and solve a problem as to figuring out the Ka for a weak acid. In this case, they give me the weak acid, uric acid, and the concentration of H3O plus at equilibrium. And I know I started with 0.11 molar of the acid before anything happened. Well, I don't know the formula for uric acid, so I'm just going to go HA for some generic or general weak acid. And in order for it to be an acid, it needs to be stuck in water, because once you put it in water, then it will dissociate into ions. Acids, we know, donate protons. So if this H plus is donated, the H2O becomes H3O plus aqueous, and we're left over with an A minus ion. From that, I can write my Ka expression, which is concentration of hydronium times concentration of A minus all over the concentration of the weak acid, HA. I don't put the water in because it's a liquid. Now it says the initial concentration of the acid is 0.11. So initially, my acid is 0.110 molar, and I don't have any ions to start with. As the acid starts donating a proton to H2O, it's going to start forming those ions. And then it says at equilibrium, I have 3.4 times 10 to the negative 2 molar of the hydronium ions. So let's try and figure out our problem. Well, Ka is simply the hydronium, which is 3.4 times 10 to the negative 2 times A minus. Well, if you notice from our equation, every time one HA breaks apart or combines with one hydronium, I should get, or one water, I should get one hydronium and one A minus. So if my hydronium was 3.4 times 10 to the negative 2, the A minus should also be 3.4 times 10 to the negative 2 molar. It's a 1-to-1 ratio. So I actually know A minus at equilibrium as well. Now I just need the HA. Well, I started with the HA concentration to be 0.11. However, some of that HA is being split apart into H3O and A minus, which means I don't have 0.11 molar anymore. So to find out how much I do have, I take what I started with, 0.110, and I have to subtract out how much split apart. Well, every time one of these split apart, I got one hydronium. So if I got 3.4 times 10 to the negative 2, that's how much hydronium, 0.034, must have split apart. When you take your 0.11 minus the 0.034, you end up with 0.076 left at equilibrium. So that goes down here, 0.076. When you multiply the top 2 divided by the bottom, I believe you get a Ka of 0.015.